Hey, fifth graders. All right. So we're going to have gone through all of chapter 11 with me wearing my back in my day. You probably can't see it, but it says we had 9 planets because we haven't, we haven't gotten there for me, but maybe you've gotten to the point where we've talked about the planets a little bit. But of course, we used to have 9 planets. Pluto used to be a planet, but now Pluto is no longer a planet. It is a dwarf planet. So that's the joke. And if you look there, I don't know if you can see it, but Pluto is got a frowny face. He's sad. So poor Pluto. Anyway, all right. So 1111 is talking about composed figures, is what it calls them. But basically, it's finding the volume of boxes with weird shapes. So we've already talked about this in morning work, but we're going to talk about it again just so that you have kind of an idea of it. So let's say that we have a figure that looks like, apparently this looks like a chair. Or a toilet, depending on how you want to look at it. Pretend that these lines are straight. Some of them are angled really weird. We'll just go ahead and fix that just so it doesn't make my brain sad. Okay, that's not too bad. All right, so we have this shape. And, oh, that's bad too. There we go. Slightly better. You guys can just watch me fix this thing. There. Okay. Close enough. So let's say that this is 10. We'll say inches. And this is, I don't know, it looks like about 20. Sure, why not? 20 inches. We'll say that this, going back here, this is going to be 6 inches. Coming up here, this is going to be 8 inches, and this is going to be 12 inches, and this is, we'll say 2 inches. I don't know if that makes sense, but that's okay. All right, so we've got this weird shape, and hopefully you can see it with the glare. I apologize again for that. And I want to know what the volume is for this shape. This looks intimidating, right? Because you guys know that figuring out volume involves multiplying length times width times height. But I mean, we've got heights here, we've got heights over here. Things are different. There's not just 3 numbers anymore. Now there's like 6. It's crazy. How do we figure this out? Well, the way to figure it out is to break it into easier chunks. And you can break it into lots of easier chunks, but really we only need to break it into 2 easier chunks. So the first thing we have to do is we're going to say, I'm just going to pick, we could do it, really what you want to do is you want to find the connecting piece. So you could either do it, break it into this section here and this section here, or you could break it into this box down here and this box up here. It doesn't matter which you choose. I'm going to choose this one just because I like it. All right, now, if we're going to say that this is actually 2 shapes that are just kind of sitting on top of each other, then we need to know, all right, well, what pieces of information do we no longer need, right? Like we've got a whole lot of things, but they don't necessarily all apply. All right, so the 10 inches here, this still applies, right? Because this is 10 inches going across, 6 inches going back, that's fine, 8 inches going up, cool. All right, now, they probably would have given us, I don't know, I'm guessing this would have been like, well, if this is 2 inches, I guess this would have had to have been 8 inches here. Sorry, that would have been there also. Okay, now, do we need this 8 inches? Do we need to know where this is? Not really, not for finding volume. Okay, so we could just ignore that. All right, do we still need the 12 inches? Well, yeah, because we want to know how tall this thing is. Do we need the 2 inches? Of course we do. Do we need the 20 inches? Well, no, because 20 inches is this, and we don't need that anymore. So we can get rid of that. Okay? So now it's broken down into a relatively simple thing. The only question you might have here is, all right, so we'll do this bottom one first, actually. Let me not jump ahead. All right, so the volume of this one, I'm just going to call this volume 1, right, because this is shape 1, I guess, is going to be 10 times 6 times 8. Okay? Well, 6 times 8 is 48, times 10 is 480. And since it's a 3D shape, it's now inches cubed. Now here, notice that we've crossed off this, we've crossed off this. We have 12 and we have 2, but that gives us the height and it gives us the width. But what about this length? We don't know what this is. But we do know what that is, right? Because unless we're told otherwise, we have to assume that this distance here is the same as this distance here. And that is the same as this distance here. And this is the same as this one, which is the same as this one. So this is actually 6 inches right there. Okay? So that means that the volume of this second little box that's sitting up here is going to be 6 times 2 times 12. Okay? Obviously, you're just going to multiply these together. 6 times 2 is 12. 12 times 12 is 144. Okay? So now we know that volume 2, the second box up here, is 144 inches cubed. And this one here is 480. So to find out the whole volume, all we have to do is we're going to add volume 1 plus volume 2. So we're going to do 480, 480 plus 144, which is going to be 4 to carry the 1, 624. I could probably write that not all on top of itself. And hopefully you can still see that. Okay, okay. So down there, 624 inches cubed. Okay, but all I did was I figured out this volume, I figured out this volume, and then I added them together. Super easy. There is a third way to do this, and we're going to talk about this just real quick here. Another way that we could have done this, and I'll just stay with the same problem here, is rather than adding two things together, is I could have used subtraction. So this one over here was 20 inches. Okay. Now, we could look at this, obviously, as two boxes sitting on top of each other, right? That's how we did it the first time. But we could just as easily look at this as one big box that has had a chunk pulled out of it. All right, so if we extended this up, this over, this up, and this over, right? Hopefully you can kind of see that there's this extra little box right here that we've removed, okay? So if you think about, I don't know, what would be a good example? Yeah, Jenga. If you're playing Jenga, right, and you just had stacked them up, maybe you're playing with your little brother or sister and they don't know how to set them up right, where you alternate the direction they're going. They just have them all together. Well, you could pull one out, and it would kind of be like you just pulled this section out, okay? So here, what we would have to do is we would need to figure out the overall volume of this bigger box and then the volume of this little box and then subtract. So in this case, we do need the 20, we do need the 10, and we do need the 6. We don't really care about this 8. That one doesn't matter anymore. Well, actually, it kind of does matter. Hold on. Let me rephrase that. That still sort of matters because we're going to need to figure out other distances. This one still matters. This one still matters. The 2 doesn't matter anymore because that's kind of irrelevant. All right. Yeah. In this case, all we took off was the 2. All right. So first of all, let's look at the big one, right? So the volume of the big shape. So we'll say we'll call it volume B because it's big. Is going to be 20. That's the height of this tall shape here, times 10, which is the width, right? Times goes 6 back, so it's going to be like that. All right. So 20 times 10 is 200, times 6 is going to be 1,200 inches cubed. Okay. All right. So that's the volume of this big box. Now we have to figure out what is the volume of the thing that we've pulled out. Well, it's 12 tall, right? Because we got this 12 in here. It's 8 wide, and it's still 6 thick, or 6 going back. The length is 6. That's what I'm trying to say. All right. So now we are going to have 6 times 8 times 12. You see that? Okay. Okay, good. We'll call this volume S, which is volume of a the smaller shape, I guess, that's pulled out. All right, so this one's going to be less easy math. This is what I get for not picking my numbers carefully. All right, so 6 times 8 is 48. Then we're going to do 48 times 12. I'm talking for too long. I've done all these lessons together. Let's see, 48 times 2 is 96, plus 480. 26, 7, carry the 1. 576. All right, so this equals 576 inches cubed. Okay, so now our volume of our composite, so we'll call that volume C, which is just going to be the purple shape here, is going to be 1,200 minus 576. Okay, so we're just going to do the subtraction here. 576. So 4. This is going to be a 2. Can't do that, but it's going to be 11 minus 5 basically, which is 6. 624, which I feel like that was the. Pretty sure that's correct. Hopefully I didn't screw anything up in there. That should be right to the problem, or the way I solved it earlier. I should have kept that written down, but I didn't. So anyway, you guys will know if I'm right or wrong. But that's kind of the whole thing. Let's see. Did they give you anything crazy in here? No. The one to be very careful of is number 4 on page 701. Just keep in mind the fact that so if you look at the inside of that shape, let's just draw it. So this is number 4 on page 701. Okay, so they give you a shape that looks sort of like this. Let's see, so we can that. This goes down. That. Over like that. And then it's going to come up something like this. And over. Okay. Maybe not the best drawing, but it looks roughly like that. All right. And then they have, I'm not going to put the units on here, but it's 2 centimeters. This thing here goes like that. And it says this is 6. 10 centimeters up here. 3 centimeters right here. Well, apparently I'm putting the units on that one. And 2 centimeters here. And then this is the part that's tricky, is they say 3 centimeters here. Okay, now, I don't know why they put that line there, but they did. Whatever. All right, let's just put our units on because it's going to drive me crazy otherwise. There we go. Okay. Now, this is a case where I would probably choose to cut this into 3 shapes as opposed to just 2. It's kind of up to you. But really the thing that you have to pay attention to is this right here, this 3 that's kind of tucked away. So if we were to, no, that goes there. All right, so this is going to get messy if I keep doing this. All right. Not great. In fact, I've screwed something up here, I feel like. But that's okay. Basically, the point is that that 3 there is not the distance from here to this line. Because remember, this actually extends up a little farther. Okay? So really what that's saying is that that 3 is the length of this leg coming down. Okay, and it's kind of hard to see it because on my picture it almost looks like these distances are about the same. They did a better job on theirs of making it clear that that was So it's like that. Okay. 2 centimeters here. Okay. So this 3 extends up. Basically, this 3 is this distance here. All right. So you could, let's use a different color. You could say, okay, so this here, this is 3 centimeters. All right. And since we know that, let's see, how does that help us? 6 centimeters. Ah, I missed one. That's how it helps us. All right. And then they've got a 4 centimeters here. That's why. Okay. So this 3 is 3 centimeters there. That's basically this distance coming down from this piece here going down. So it's 3 centimeters there. But over here, it's 4 centimeters. All right. This is basically 1 centimeter shorter than this side. Okay. So my suggestion would be to cut this way. All right. So if this is 4 centimeters here, that means that this is 2 centimeters here and 4 centimeters down here. Okay. We already know, because of this, we know this distance is 3 centimeters. All right. And we basically are going to ignore this 6. Okay. Over here, we've got 3 centimeters down, 2 centimeters, and then again, because of this, we know that this is 3 centimeters here. We're going to kind of ignore this one. We're not actually ignoring it. We're just moving it over here. All right. So now this is 3 wide, 10 long, and 2 tall. This one is 4 by 2 by 3, and this one is 3 by 3 by 2. Okay. So basically, you'll have a volume 1, volume 2, volume 3 that you'll add together. And I'll let you figure that out. I don't think at this point you need my help with that. Just something to be careful of, because that one can be kind of tricky. All right, so congratulations. This is the last lesson of our Go Math workbook. You got all the way through chapter 12, or chapter 11. Sorry, all the way through chapter 11. Good job if you made it this far. If you didn't make it this far, I don't know why you're watching this video. That's a weird thing to do. The test is it's a lot of obviously it's a lot of everything that you've just gone over. I think I might have stuck on. Here's one last little thing that I've talked with classes in the past about. It is in no way part of the 5th grade curriculum. Should be, because it's easy, but it's not. So we talked a little bit about how to figure out the volume of cylinders, and in particular, we did that because I've had classes in the past that were like, "Oh, Mr. Lewin, this is so easy." And so I was like, all right, well, let's try something a little harder. So the volume of a circle, or not the volume of a circle, the area of a circle, right? Oops. So this is a circle that's tipped over. I guess let's do it this way. All right. So area equals pi times r squared. Now, that probably looks a little scary to you guys, but it's actually not. So first of all, r is just a radius, okay? So r equals radius, which is distance from center of a circle to the edge. Okay, pretty easy. Now, pi is a number that goes on for forever. A lot of you guys know that. However, all I want you to use is 3.14. And get used to that number because, oh boy, is it going to show up a lot. Now, squared just means, well, I say base times base, but I hesitate to say that because you guys have just been doing polyhedrons and things, and so in your mind, maybe base means like the bottom of a, or not the bottom, but the base of a pyramid or a prism. In this case, base means r. So really what this is saying is that the area of a circle is equal to 3.14 times the radius times the radius. Okay? So squared, if you think back to like our powers of 10, right? 10 to the power of 2, 10 squared was just 10 times 10, which is 100. Okay? Same thing here, only this number is not necessarily going to be 10. Though I do tend to pick easy numbers for you guys because I don't want it to be too crazy. All right, so with this in mind, if you think about how do you figure out the volume of a prism, right? Let's erase this. Something like that. Okay, so here we have our little prism, right? Well, here you have your length and your width and your height. But couldn't you just say that the base, so this bottom part is going to be length times width, and then volume equals base times the height, right? Because length and width is going to give you the base part, and then you just multiply the height times that. Well, if that base is in fact not a square or a rectangle or a triangle or any other shape, but is a circle, then you could say that the volume of a cylinder, I feel like I just misspelled that. That looks better. Is going to be base times height, right? Same as everything else. But in this case, the base doesn't equal length times width because we don't really have a length or a width. Instead, what we have is we're going to say that the volume is equal to pi times radius, which is r squared, right? Times the height. So let's pick some numbers here, and I'll just show you really quickly how to do it. And the reason why I do this is because I think there's an extra credit problem on the test that involves you figuring out like what is the area of this shape, and then I give you something crazy that's like a box, but then there's like a circle cut out in it, essentially. Something like that. Anyway, you get the idea. Totally up to you if you want to do it or not, but it's just for fun. So let's say I'm going to pick a real easy radius. So we're going to say the radius equals 10 inches. All right. So if a radius is 10 inches, that's pretty short. Let's say 1, 2, 3, 4. We'll say this is 40 inches. Okay. So with that little bit of information, we can figure out what the volume of the cylinder is. So the volume equals the base times the height, which in this case means pi times our radius squared, times our height, which is going to be 3.14 times 10, and you guys already know, well, let's say 10 squared times 40. All right, then we just goes through this. All right, so you have 3.14 times 10 is 100 times 40. All right, well, fortunately, I know that 3.14 times 100 is just moving that decimal twice, so it's going to be 314 times 40, which is going to be a little harder math, but that's not too bad. 314 times 40, we have a 0, 4 times 4 is 6, carry the 1, 4 times 1 is 4, plus 1 is 5, 4 times 3 is 12. All right, so this is going to equal 12,560 inches cubed is your volume. All right, not too hard, right? Some of you guys totally are going to get this right away. Some of you not. That's okay. Don't worry about it. This isn't 5th grade stuff. This is 6th and 7th grade stuff, I think. Not quite sure which. Anyway. Have a good one. I hope you've enjoyed math this year, and I miss you guys. I wish that we could be doing this together. It'd be a lot more fun if I was blowing your brains in person rather than through YouTube or whatever. So anyway, have a great summer, guys, and I'll talk to you later.